Okay, in this lesson we are going to be looking at having variables on both sides of the equation and then solving them. So your goal here is to get everything that has a variable in it on one side of the equation and everything else on the other side of the equation. And so for this particular one here, you want to get the y, anything that has a y on it on one side and anything else on the other. You can choose to do this in several different orders, but what I would choose to do is I would move this y that's on the left side over to the right. Right now it is negative y, so I'm going to do the opposite and add y. The reason I'm moving it to the right is just so that my y's are positive. Some of you may have taken the 6y and moved it to the left, and that is fine too. But those drop, and I have a positive 6 on the left, and then 6y plus 7y, or 6y plus 1y makes 7y plus 3. And then, of course, I would subtract 3. Okay, and that would drop. And 6 minus 3 is 3 equals 7y. And then in order to solve for y, you need to divide by 7. And so y would be 3/7. And I know we got a fraction here, but that's okay. Just because you got a fraction does not mean you did it wrong. Some of you at the beginning may have chosen to move your numbers first, like move the 6 or the 3 to one side of the equation first. That would be totally fine as well. All right, here we need to do some combining using the distributive property. Common mistake that people will do is they will add 6 plus 5 here to make 11 and then distribute the 11 times the d minus 2. Remember, your order of operations says you need to multiply, which is what you're really doing when you do this first before you can add and subtract. Okay, so on the right I will have 6 plus 5d, and then 5 times negative 2 is negative 10. And then it's helpful if you can combine all your like terms on each side of the equation first. So I have 6 equals, I will combine this 6 and this negative 10 to make negative 4 plus my 5d. Okay, I have no d's to combine anything with, but I will add 4 here. And then I will have 10 equals 5d. And then, of course, to solve for d, I need to do the opposite of multiply, which is to divide. And so d will be 2. Okay. All right. Here's another one where we have to do a little distributing first. A lot of people will just think that you can drop this parentheses right here, but you are subtracting this whole quantity. And so this is one of the very most common math mistakes you will ever see in even upper level mathematicians. When you have a negative right here, this is really like having a negative 1 in front of here. Okay? It means the same thing as having a negative 1. That negative 1 needs to get distributed through the parentheses because you are subtracting the whole quantity x plus 4. So a lot of people will write this. Okay? If you wrote that, you made a mistake. You are subtracting the whole quantity. So I need to not only subtract the x, but I need to take negative 1 times x so that I subtract the x, and negative 1 times 4 makes this be negative 4 right here. Okay, and then on my left side, I have that. Okay, now I'm going to combine my like terms. So on my right, I have this negative x right here. And then I have 2 plus negative 4. And 2 plus negative 4 makes negative 2. And now I want to get everything with an x on it on one side and everything without an x on it on the other. So I will add x. That will drop. Negative 5x plus x makes 4x. Bring down the 10. Equals, be careful, make sure you remember to put that negative with a 2. Negative 2. Then I want to isolate the things with an x in it, so I need to move this 10 over. It's added, so I will do the opposite, which is to subtract it. Then I will have 4x equals negative 2 minus 10, or negative 2 plus a negative 10, if you want to think about it like that, is negative 12. And then, of course, it's 4 times x. I will do the opposite of times, which is to divide. And x will be negative 3. All right, here we just need to combine some like terms on both sides first. So on the left side, I will combine this 2x and this 3x to make 5x. And I will combine the negative 4 plus 1, which makes negative 3. On the right side, I have negative 2x minus x, so that makes negative 3x. And then this is a positive 12 right here, so plus 12. Okay, and then I want to get x's on one side, everything else on the other. So I will add 3x, and I will have 8x minus 3 equals 12. I've got all my x's together now. Now I want to move my constants, so I'm going to add 3 to both sides. And I will have 8x equals 15. I have 8 times x now, so I will do the opposite of times, which is to divide. And oh my goodness, we're getting a fraction again, which leads people to believe that they've done it wrong. But the answer here is 15/8. Okay? All right, here's one for you to try. So go ahead and do this. Hit pause, try it, and then I'll show you the answer here step by step so you can check it. All right, here we've got something with the distributive property on both sides of our equation. So we can do this no problem. On the left side, I will distribute 9 times 4y and get 36y. 9 times negative 1 is negative 9. On the right side, 2 times 9y is 18y, and 2 times 3 is 6. All right, and then I want to make sure everything that has a y on it goes on one side, and everything else that does not have a y on it goes to the other side. So I'm going to move this 18y from the right to the left so that I can combine it with my other term that has a y with it. That will drop, and I will have 18y, bring down the negative 9, equals, I've got this positive 6 left over here. All right, and then I've got all my y's together, but I do not have my constants together, so I will add 9, because negative 9 plus positive 9 makes 0. And then I will have 18y equals 15. Divide by 18. And y would be 15/18, but I do want you to reduce that if you can. And of course, 15 and 18 are both divisible by 3. So 15 divided by 3 is 5. 18 divided by 3 is 6. And that's what you get. All right, now we've got ones with fractions in them, but we don't need to be so worried about it, okay? So it's okay. You're still going to follow the same process. You're going to get all your x's, things that have terms that have an x on them on one side and everything else on the other. So I will add 1/10 x. Okay, this will drop out. Of course, you'll have just 6 over here. Now you need to add 2/5 plus 1/10. I'm going to do this off to the side just so that it's a little cleaner. So 2/5 plus 1/10. Remember that when you add fractions, you need common denominators. And when you get common denominators, your common denominator here is 10. So I'll multiply both of these by 2. And then that becomes 4/10 plus 1/10, which of course we know is 5/10, which is 1/2. Okay, and it has an x with it. So 2/5 plus 1/10, 2/5 x plus 1/10 x is 1/2 x. All right, and now we've got all of our x's combined together, and I will move my constants, so I will subtract 3. And then you'll get 1/2 x equals 3. And of course you want to do the opposite of multiplying by 1/2. And to make that be 1 in front of the x, I will multiply by the reciprocal, which is 2/1. That will drop. And 3 times 2 over 1 gives me 6. All right, in these next couple, there are some unique things that happen that I want to show you because people get these mixed up all the time. So, here we go. This is not the one I want you to see. All right, here we go. This is the one we want to do. So, we have 4 times x plus 20. So, here we go. 4 times x is 4x. 4 times 20 is 80. Okay, now on the right side, I know we have a fraction, but remember that multiplying by 1/5 is the same as dividing by 5. So if you think 20 divided by 5 would give you 4x, and 400 divided by 5 would give you 80. Okay, so now I want you to see that you have basically the same thing on both sides of the equation, but watch what happens. Okay, so I will subtract 4x. And then I want you to notice this. All of your x's are gone here, and all of your x's are gone here. So there's no x's left in this equation. And what I have left then is I have this 80 equals 80. Okay, now, when all of your x's drop out, all of your variables drop out like they did in this case, you have 2 choices. Your choices are either to have it be no solution or all real numbers is your solution. Okay? If what you have left is a true statement, so in other words, does 80 equal 80? Yep, 80 does equal 80. If 80 equals 80, that's a true statement, and there is no number that won't make that true. So my answer to this solution would be all real numbers. You can write it like that. You can also write it like this. That's the symbol for all real numbers. Okay, so either way would be fine. That's the symbol for all real numbers. So that's one thing that could happen when all your x's were to drop out. Now, this is not on your note sheet, but let's talk about this. If I have this, let's say, 4x plus 20 equals 4x plus 30. Okay, and I solve this now. So if I subtract 4x, again, all of your x's are gone. I have no variables left. But I have a 20 on this side, and I have a 30 on the right side. That is not a true statement. 20 will never equal 30. It never, ever, ever equals 30. So your answer here would be no solution. Or if you want to write it like that, that is the same thing as saying no solution. Okay, so when all your variables drop out, you have 2 choices, either all real numbers or no solution. It's all real numbers if what you have left is a true statement, and it's no solution if what you have left is a false statement. All right, and lastly, onto this word problem here. 5 times the sum of a number and 3. So the hardest part here is to actually just get the equation set up, so that's what we're going to do. 5 times the sum of a number and 3. Sum means to add, so I'm adding a number and 3, but I need to take 5 times that sum. So in order to say that I'm taking 5 times that sum, I need to put this in parentheses. Otherwise, I would just be taking 5 times the x and then adding 3 to it. All right, that's the same as. So same as is another words for equal. 3 multiplied by 1 less than twice the number. So here's twice the number. 1 less than that, I would subtract 1, and I'm taking 3 times that quantity. Okay? I am going to let you solve for that. I will tell you that when you do that, you get x equals 18. But the hardest part to that problem is to come up with the equation. So that's what it should look like.